questions to go over from the homework. 6B. Ah. Well, I think the first thing, and I think I told you this is an A+ level question. This is harder than I'd feel comfortable asking you. Okay, maybe as a multiple choice where you have the answers to pick from, you could always work your way backwards by trying which answers work. Yeah, whatever. Make it equal to 0. So I'm going to rewrite this as 2 sine x cos x plus 2 sine x minus cos x minus 1 equals 0. There's 4 terms. I'm going to try factoring by grouping, not groping, Justin, grouping. I'm going to try to see if I can I'll draw the line in my mind. I won't draw that physically because it really, I run out of room. GCF in the first 2 terms? Oh yeah, there is. Two sine x, leaving me a cos x plus 1. GCF out of the last 2 terms. Oh, there is. What? Ah, you see where we're going now, don't you? Leaving me a cos x. Oh, cool. I guess my factors are going to be cos x plus 1 and 2 sine x minus 1 equals 0. It's going to be kind of neat. What are my roots? Cos x equals negative 1. Well, alarm bell, try unit circle or what, because that's not going to be a special triangle question. And sine x equals 1/2. Do I have a triangle with a 1 and a 2? Oh, yes, I do. And I take it from there. I think this will give me, I've done this one so often, I'm pretty sure it's pi by 6 and 5 pi by 6, because I've just done this one so often, I've eventually memorized this thing and answer. This one here is going to be, where is cosine negative 1? I think it's pi. I think. But I'd show some kind of work. Okay. I do like that in that, Carly. Hey, it's a nice review of factoring by grouping. So you're going to move over there now? Just, okay, cuz? Yeah. Yeah. Any others? Or D as in dog? Sure thing. What kind of equation is this? A quadratic. How do I know? It's got a square. Make it equal to 0. So I would do this first. Factor. Oh! It's the first thing I always look for. What's the first thing that I always, oh yeah, and there is one. Cos. And I get 2 cos x minus root 3 equals 0. I'll get, for this one, cos x equals root 3 over 2. Do I have a triangle with a root 3 and a 2 in it? I do. It's going to be the 1, 2, root 3 triangle, I think. Pi by 6 will be a reference angle. I'll have to kind of visualize it a bit more. Ah, what's my root here? A 0. Oh, alarm bell. Where's cosine 0? I think cosine is 0 here and here. I think it's pi by 2 and 3 pi by 2, but I'd have to draw it out on the unit circle. For goodness sake. Okay. That one I think is totally fair game. I kind of like that question. Glad you had one or not. Number 10. Oh, yeah. Where is the A? Inside a logarithm. And inside a but inside a logarithm. What did we do? Okay, this is good review, which is kind of why I signed this. When our variable was inside a log, we said if I know one, I know both. We rewrote it. What to the power of what equals what? And this is for anybody out there. Heck, I'll even throw a candy out there. Rewrite this as an exponent. Alex. 4 to the negative 1 equals sine squared a, right, Vlad? That to that equals what's inside the log. And then Alex went one step further. He said, oh, and I know that a negative exponent acts like an elevator. 4 to the negative 1, that's really the same as 1 over 4. Now what? This is a quadratic, except this is the nicer quadratic. There's no linear term. There's no sine with no squared. I can get the sine squared by itself and say to myself, how do I get rid of squared? This is going to be the sine of a equals, what's the square root of 1? 1. What's the square root of 4? 2. Oh, plus or minus. Do I have a triangle with a 1 and a 2 in it? It's going to be the 1, 2, root 3 triangle. And there's going to be 4 solutions, 2 positive, 2 negative, and take it from there. Okay. Then I need to realize it says angle A is acute. That means less than 90 degrees. So all they want is your first answer. I think it's going to be pi by 6 because I'm pretty sure the reference angle that has a sine of 1/2 is pi by 6. I've done it so much. And I think since that's your reference angle and they want the smallest acute angle, that'll be your answer. I think the answer will be pi by 6. Any others? Then turn to lesson 3. Lesson the third. Page 329, I believe it is, if I've got my bearings correct. No, 325. And you absolutely have to have a graphing calculator this lesson. Now that I've loaned calculators out to the 3 people who came unprepared. By the way, you're going to need one on your test, and I guarantee on your test I will not loan you one. I find it insulting and almost arrogant for a kid to show up for a test and say, you loan me a calculator? I almost want to toss them out of the room. You want to get paid, but you didn't bother doing any work or bringing your uniform or bringing your tools, and you still think I'm going to pay you? Not a chance. There's your, make sure you're in radians, especially those of you that borrowed one. And the heading says, equations which require a graphical solution. On your test, I'm going to give you one multiple choice question that you can't solve by hand. And I'll tell you how you'll spot it in a second. Some equations, it said, can't be solved by an algebraic approach. We fibbed. Some equations can't be solved without using a calculus-based algebraic approach. Those that are in calculus, probably in about 3 weeks after spring, not counting spring break, you'll learn what's called Newton's iteration method, which is a method that will solve any equation out there. What it does is it uses derivatives to make an educated guess, and then you take that derivative to make a better guess, and you take that derivative to make a better guess, and you can keep making better and better guesses, and it very rapidly, after about 4 guesses, gets you accurate to about 8 decimal places, which is about as good as we need to get. Here, we don't have that option. Consider this equation right here. That guy. One way to recognize that you can't solve this by hand, Brianna, is to notice that there's x's inside trig and there's x's not inside trig. There's an x inside a sine, and there's just a plain old ordinary x. You see, our normal methods won't work. I can get the sine x by itself, but I got an x over here, so it doesn't help me. I can get the x by itself, but I got sine x over here. Getting them to the same side won't help me much at all either. Instead, what we're going to do is we're going to graph. We're going to graph. So it says this, use the following graphical method, and it's giving me a domain. It wants me to do this over the domain between 0 and 2 pi. First thing we're going to do is type in the equations. Now, I normally graph this as y1 and this as y2, but I noticed that they went with the right side as y1 and the left side as y2. So let's follow their method. So let's turn on our calculator. Clear any equations we have. Clear any equations you have here. And type y1 equals x, enter, and y2 equals 3 sine x, enter. But I'm not going to hit graph yet. If you did, that's fine. I want to change my view window too. What domain for the x's do they want me to go looking for an answer in? 0 and 2 pi. I think mine already is that, actually, as it turns out. And it decimalizes it. That's fine. Scale, Justin, my fallback scale, when in doubt, if I don't know what to do, I go 30 degrees, or what's 30 degrees in radians? I go pi by 6. That's how I do my x's. My y's, I have to think about a little bit. What's the amplitude of this graph? 3? You know what? Then I'm going to go from -4 to +4, because this graph is going to go 3 up, 3 down, 3 up, 3 down. And if parts of my graph vanish off the screen, I might need to quickly redo my window after hitting graph. Before you hit graph, here's how you write the window instructions. So I told you to go from 0 to 2 pi, pi by 6. It always goes minimum, maximum, scale. How would I write my y? Based on this, I think I would write this. Minimum, maximum, and the y scale I think we picked was 1, yes? Just in case they ever ask you to write a window. I won't, but who knows. And hit graph. First question. How many answers are there? 2, because the answers occur where these two graphs do what? Intersect. If this was multiple choice, you might be done. You might only have one answer that has 2 solutions. Probably not, but you might be. I'd certainly cross out anything that had more than 2 solutions. Not only that, I'm pretty sure one of the answers is right there. What do you think that answer is? Pretty sure 0. You might, Ryan, only have one answer with 2 solutions, one of which is a 0. Well, then quit. Save yourself the time. But let's assume that we didn't. We're going to go intersection. Now, where's that? Second function, calculate. Option 5, intersection. Now, Spencer, what did we think that this answer was? So, first curve, I'm going to hit enter. Second curve, I'm going to hit enter. Because there's only 2 curves, I can just go enter, enter. For my guess, I want to see if I can find that 0. So I'm going to do a guess of 0.1. Enter. Oh, mine didn't find the 0. Did yours? Okay, I found the other root, the other intersection, the other answer. Let's write that down. What's the other answer? Now, let me pause. Is there anybody that can't get that to go? Ryan, you're good? Oh, okay. What's the answer? How about 2.28? Oh, it says to the nearest tenth. My second x value is 2.3. I'm pretty sure this first answer is 0, but this gives you some of the limitations of the graphing calculators. And one of them is, if your root is right on the edge of your domain, if your intersection is right on the edge of your domain, Maria, they got a tough time. So you know what? Let's cheat. Go back to view window. And let's move the whole graph to the left a bit. I'm going to go, instead of starting at 0, I'm going to start at -0.5. -0.5. And hit graph. Well, now I can more specifically see for sure that it definitely does go through 0, 0. But now I think if I go second function, calculate, intersection, first curve, enter, second curve, enter, guess of 0.1, I'm willing to bet now it will find the, it did find the 0. x1 is 0. Trevor, that's how you can use your calculator to find the answers between this domain. What if instead they ask for the general solution, which means all of the answers that exist? Usually what I do is I tend to zoom out a bit. So I go back to my graphing calculator, window, and until I get a good handle on what this looks like, I usually go 3 periods left and 3 periods right, which is going to be -6 pi and +6 pi. And I'm just randomly guessing right now, but I'm going to try that. Oh. First of all, how many answers are there? 2.3, and I think I can zoom in a bit more, so I zoomed out way too much. I don't like this window. I'm going to go mode, whoops, sorry, I'm going to go window. How about negative pi to positive pi? I kind of looked at my graph and I noticed my hash marks, and I said if I go 6 hash marks left and 6 hash marks right, that should, let's see. Oh, yeah, that's nice. And by the way, Alex, can you tell, based on this graph, there are no more roots to the left because this is going to be going down further and further and further. It's never going to cross the sine graph again. And there are no more roots to the right because it's going up higher and higher. It's never going to cross again. Let's find this one. Second function, calculate intersection. First curve, enter. Second curve, enter. Guess. About there. Enter. Oh, it's symmetrical. Positive 2.3 and negative 2.3 and 0. So write the general solution. Negative 2.3, 0, positive 2.3. Hey, wait a minute, Mr. Dueck. I thought for the general solution you were supposed to like add the period or something. The general solution is simply tell us all of them. Here, since there's only 3 grand total, maybe there's a pattern that I could find, Alex, to write this as one statement. Heck, there's only 3. List them. If it continued repeating, I'd have to figure out some kind of a what's the period, what's the distance between the answers, spot the pattern, and add multiples of the period. Here, C says, describe how we could find approximate solutions using the 0 feature. I hate the 0 feature. It's very poorly designed, so I'm going to skip that. Thank you for turning the page without making me tell you to turn the page. So example 1 says, use a graphical approach and the 0 feature. No. Cross out and the 0 feature. Use a graphical approach of the calculator to find the solution to that. And give answers to the nearest 10. Okay. How can I tell that I'm supposed to use a graphing calculator? Because they told you to, Mr. Dueck. Yeah, okay, what if they hadn't? Again, Trevor, can you see I got some x's with no trig and some x's with trig? Probably need a graphing calculator. So clear whatever y values you have. Go y equals and clear whatever graphs are there. I'm going to graph the left side as y1, x to the third minus x squared. y2, 2 sine x. And then, Maria, I'm going to hit view window. I know what this graph looks like. This is the sine graph with an amplitude of 2. And you guys know what this graph looks like? I don't. So I'm going to hedge my bets. I'm going to go negative 6 pi. 2 periods left. 3 periods left. Positive 6 pi. 3 periods right. What's my fallback when in doubt scale? Pi by 6, which it already is. Dominique, what's the amplitude of this trig function? How high will it go? How low? I'll go between negative 3 and positive 3 then, kind of center it. Try that, hit graph. Oh, I can zoom way in. I think I can zoom pi left and pi right for that matter. So let's go view window really quickly. And let's go negative pi and pi. Let's try that. Is it working okay, SR? You sure it's working okay? Yeah, okay. I get this. Yeah? So you get 2? Good, find the intersections. I'll freeze the screen, try it on your own. There's 3 of them. I'm pretty sure 0, 0 is 1, but I'll double check. I got that. I got negative 0.9, 0, positive 1.7. How will this look on your test, Justin? Justin, I'm going to give it to you as a multiple choice question. And I told you that I would tell you how you can instantly tell that this is a graphing calculator question. And you can. I gave you a trig review last unit. You don't need to get it out. I'll just show it to you. Trig review number 1. The one that looked like that. Okay? And I'm just going to scroll through and I'll show you how I can instantly spot a graphing calculator solving question. Number 10 is for sure. You know how I know? What do you notice about all your answers? Decimals. It's that easy. That's graphing calculator. Graph left. Also, because I noticed there's a tangent and a sine. No problem. Graph left side, graph right side. Find where they cross. Is that big enough, Carly, for you to read? Good, then solve it. Go, all of you. And tell me, is the correct answer A, B, C, or D? Notice the domain restriction between 0 and 2 pi, so make sure you change your window accordingly. As a graph, do you get this? Emily's looking a little puzzled. What's the matter? I have no idea what you said. Okay, so match your... Anybody else not get this graph? Okay, we come help you. Everybody got this now? If you didn't, look up anyways, because I need you to catch some important things about where the software breaks down. When I say look up anyways, that really means look up. Okay? That's not an answer. That's your calculator not knowing what to do with an asymptote. That's not an answer. And if you have a newer calculator, like an 84, it might not even have those lines there. Does it? Nope. So how many answers are there? 2. I would be going boom, boom. And not only that, look at the first 2 answers right there. Do you think that x value there is 0.5 or 2.06? Well, this whole thing is 2 pi, which is what as a decimal? Roughly 6.28. So what would this be? Pi, or as a decimal, roughly what? 3-ish. I'm pretty sure that's closer to 0.5 than 2. You actually don't even need to go second function, intersection, solve. I'm positive, I guarantee the answer is A. Now, I'll do it. Second function, calculate, intersection, first curve, second curve. I'll guess right here, enter. Yeah, 0.49. Do be aware that, I don't know if this one will, first curve, second curve. Sometimes it thinks this is an answer. I'm going to stop right there and see if it wants to tell me that that is a root. I've seen it stop there hanging in midair. Okay, this one doesn't. I don't know which graphs for tangent and cotangent, the ugly cousins with the asymptotes, that it does or doesn't, but it does sometimes. You got to be able to interpret your graph a little bit. But my point is, Mitsu, often, because it's going to be multiple choice, you won't need to do the whole question. Sometimes you won't even need to do any of the question. When you're graphed, you may be done. Oh. Do you know how I know that's a graphing calculator? Look at your answers. Why am I doing such a big song and dance? Eric, every year I have a kid who misses this. And then when they get to this question on the test, they spend 20 minutes trying to solve it. You can't. Not without your graphing calculator. I'm budgeting, when I create this test, about 60 seconds for you to solve it. I figure it'll take you about that long to type, second function, calculate, intersection, first curve, second curve, get. I'm not budgeting 20 minutes. If you don't notice that it's a graphing calculator question, I won't give you the hint other than that to say, hey, the answers are decimals. You're going to spend too much time and you won't finish the test. See this one right here? Number 30. How do I know it's graphing calculator? Decimal answers. This one here says solve. How do I know it's not graphing calculator? Exact values. $45, graphing calculator. That easy to spot. Okay. What's your homework? That was a short lesson, Mr. Dueck. Number 1, all. Four and 5, 6 and 7.